Assalamu alaikum. Hello again, dear students. Now let us consider the following applications about solving an electric circuit. First, you need to know that solving an electric circuit consists of determining the currents in the different portions of the electric circuit and the voltages between the different points of the circuit. In our first application, we will take a series circuit containing a battery and two resistors. The adjacent circuit contains a battery, 6 volt 1 ohm, and two resistors of respective resistances R1 equal 10 ohms and R2 equal 14 ohms, and a switch K. What does 6 volt and 1 ohm represents? Take your time. Yes, 6 volt represents the electromotive force of the dry cell, and 1 ohm represents the internal resistance of the dry cell. Now, we need to determine the electric current traversing the different components in the circuit. The first step is applying the law of uniqueness of current in series grouping. The current delivered by the cell is equal to the current traversing the first resistor is equal to the current traversing the second resistor, and it is simply denoted by I. In the second step, you need to apply Ohm's law to the terminals of the battery and the two resistors. This gives you that the voltage UPN is equal to E minus RI. The voltage UPA is equal to R1I, and the voltage UAN is equal to R2I. Then we need to apply the law of addition of voltage in series grouping, which gives you UPN is equal to UPA plus UAN. Substitute these voltages by the previous equations gives you E minus Ri is equal to R1I plus R2I. You need now to gather the current at one side. Then I into R1 plus R2 plus R is equal to E, which implies that I is equal to E divided by R1 plus R2 plus R. Substitute these factors by their values, gives you that the intensity of the current traversing the circuit is 0.24 ampere. Now you are asked to calculate the voltages UPN, UPA, and UAN. You will simply replace the intensity of the current you have obtained in the previous part in the equation of Ohm's law of a generator and the two resistors, and you will obtain these values. Try them by yourself. In the final step, you can replace it by calculating UAN is equal to UPN minus UPA. Note that we can also solve the circuit by replacing R1 and R2 by their equivalent resistance R equivalent, which is equal to R1 plus R2 in this case. Let us now take another application. In this application, we will take a parallel circuit containing a battery 9 volt 1.5 ohms and two resistors of respective resistances R1 equal 10 ohms and R2 equal 15 ohms, as you can see in the figure. You are first asked to determine the main current I traversing the circuit. In this case, you need to start by calculating the equivalent resistance of R1 and R2. Since R1 and R2 are connected in parallel, then their equivalent resistance is R equivalent equal to R1 R2 divided by R1 plus R2. Replacing the resistances by their values gives you that the equivalent resistance is 6 ohm. The previous circuit can be replaced now by the following one, where R equivalent represents the grouping of the two resistors among each other. Now we need to apply Ohm's law across the terminals of the battery and R equivalent. This gives you that UPN is equal to E minus RI, applying Ohm's law of a generator, and UAB is equal to R equivalent I. Then you need to apply the law of addition of voltage in series grouping, which is UPN is equal to UPA plus UAB plus UBN. Notice that UPA is a closed switch which acts as a connecting wire, and UBN is a connecting wire. BN is a connecting wire, then the voltage across these two is 0 volt. Replace the following by the previous equation. Gives you E minus Ri is equal to R equivalent I. Gathering I at one side give you I into R equivalent plus R is equal to E, which implies that I equal to E divided by R equivalent plus R, which gives you 1.2 ampere. Now, after calculating the intensity of the main current traversing the circuit, you are asked to calculate the voltages across UPN, UAB, and UCD. You will simply replace the main current by its value to calculate the voltage across the dry cell, and you need to apply the law of uniqueness of voltage in parallel grouping, which gives you UAB is equal to UCD is equal to UPN is equal to 7.2 volt. Now you are asked to determine the intensity of the currents I1 and I2 traversing R1 and R2 respectively. Here you need to apply Ohm's law between the terminals of R1, which gives you that I1 is equal to UAB over R1, which gives you 0.72 ampere. Similarly, you can calculate I2, or instead of that, you can immediately write that I2 is equal to the main current you have calculated in part 1 minus I1, which gives you the same value by applying the law of addition of current in parallel grouping. Now, dear students, you need to refer to your agenda to solve the indicated exercises. Thanks for watching.